Hello everyone, welcome to our Satoshi talk. Today we are honored to be here to invite John to be our guest. John is from Geeqchain, and maybe John can give us an introduce.
Sure. So I'm a professor of economics at the Vanderbilt University in Nashville. I've been interested in the ICT, information communication technology space for quite a while. I've done things in cloud computing and various kinds of mechanism design. And more recently, I had a sabbatical at Microsoft Research, where I did much more in-depth work in crypto economics and biometrics, various sorts of computer algorithms and communications protocols. So while I was there, somebody pointed out this new phenomenon of blockchain, although it wasn't that new then, I suppose. Mm-hmm. And what was more new was these ICOs, these initial coin offerings. So as an economist, it's very interesting because really there's a lot of monetary economics as well as things that they have aspects of equities as well, and trying to evaluate how they might appreciate and what their value could be, and what the various sorts of tokens do, utility tokens and transactional tokens, security tokens. So it's a very interesting thing for an economist. So I studied it, and I ended up coming back to game theory. So I'm a game theorist, and really a validation mechanism, which is how you make sure that the transactions are correct and the blockchain's immutable, that's a game. And you have to write the game correctly so that agents have incentives to behave the way you want them to behave. So that's a problem I worked on. And I ended up getting in contact with Rick Aselstein, who is here in Waterloo. He's a person that's CEO, has been in the IoT space and the microelectronics space for, 20 years probably. And he was looking for a solution, and we found that we couldn't build things on Ethereum and other things, other platforms that were being offered.
Yeah. So what is the thing that he's trying to build?
Well, he was trying to build a market where machines, what's called machine to machine, M to M, so where machines could interact with each other and act as your agent.
Okay.
So machines could make transactions.
So like the Internet of Things.
The Internet of Things, right. So machines are connected, they want to talk to each other, and we want them to talk to each other as our agents on our behalf, not on the behalf of companies that happen to issue the agents.
Right. So what do the machines talk to each other about? In his project, or in
his project, so he's really started out being interested in industrial machines. So his initial vision was, let's imagine that you have a conveyor belt. Okay. Where you can attach sensors to a conveyor belt that detects heat, vibration, noise, things like this. When things start to vibrate and get hot, they're about to break. So what do? Well, one thing you could do is this conveyor belt could talk to other conveyor belts in the factory or in the UPS office or the Amazon warehouse and say, look, I'm about to break, run me at half speed, have all the packages, go someplace else, and when you have a chance to fix me, I'll get back online. So they can negotiate loads, they can say I'm about to break, or let's bring in another technology, let's have a repair person come in, and they can do that in a way on the blockchain that's now verifiable and lets them also exchange value, so I can actually pay for my own repairs.
Okay. So this marketplace for Internet of Things, is that like a common theme among the Internet of Things plus blockchain community, or?
Yeah. So that's certainly one of the ideas, to allow agents to transact and be your agent.
So what other transactions are there, like as use cases for Internet of Things purchasing stuff?
Well,
or like those payment scenarios.
Right. So the payment scenarios are things like many of them are micropayments. So an example might be, suppose that I'm out here on the streets of Toronto. So I've got an American cell phone. Sorry, but so I can't get connectivity.
Right.
But all of your cell phones have a wireless have a Wi-Fi connection.
Right.
So you could set up a mesh network that gives me back to a backhaul, which is some internet router here, maybe at WeWork. So I could pay you a few microcents to let me hop across your mesh network to get back to here. It costs you battery, and costs you some of your connectivity. So it still might be worth it, but I could get connectivity for very little while I'm walking around the streets of Toronto. but you're not going to do it for free. Maybe you're a nice guy, but most people need some incentive to do it. A machine can make you a couple of cents, 10 cents during the day, every day that you're walking around Toronto.
Interesting.
Yeah, that's like an ad hoc network, right?
An ad hoc network, yes, right.
Oh, okay. So what's the current solution for the Internet of Things talk to each other?
Well, mostly it's centralized.
Okay.
So they all talk to Google, or they all talk to
Okay.
Amazon. So they're all going back to the mothership.
Okay. So what's the benefit put it on the blockchain?
Then they work for you. So I don't know what Alexa's saying. You know, Alexa's collecting telemetry. My doorbell is collecting telemetry. My security devices are as well.
Yeah.
They're being taken by Google Analytics, who's doing whatever Google Analytics does.
Mm-hmm.
But if I capture that data, and for example, my devices have to write a hash of whatever it is they're collecting into a blockchain that I can verify
Yeah.
and go back and see this is what Google took from me.
Okay.
Now I'm secure. I know that this is actually what it knows. And I can also usefully let my device talk to other devices on terms that I lay out. I don't have to depend upon Google to say, well, you can only buy from me. Now these devices can interact with each other the way I want them to interact.
So this is your guys' the initial idea is to build something for the IoT, right?
So this is hardly my idea. So this
Okay.
is everybody has this idea, and the right solution is not clear. So there's lots of different use cases, different devices, different needs.
So this Geeqchain that you guys are trying to do, does it solve like this particular problem with like
Or it's
Internet of
mandate?
Things payment network, or is that more?
Yeah, it does. So there are two reasons why existing solutions are not able to address this and most other problems. For these kinds of transactions, these microtransactions, the most important thing is scalability and also cost.
Yeah.
So if you're trying to, I'm going to give you a tenth of a cent to let you use your Wi-Fi to pass on something to backhaul. I can't spend 30 cents in an Ethereum transaction to give you that tenth of a cent. So that's simply impossible. So it has to be something less than a tenth of a cent by a lot for it to be worthwhile. So you can't use Bitcoin, you can't use Ethereum, you can't use any proof of work solution. It's simply too expensive and always will be because there's a fundamental cost.
Right.
It costs $3 billion a year, or 3.2 in 2017, of electricity alone to validate the Bitcoin blockchain. So cost has to be cheap, and there are some solutions that are cheaper, but they have other problems. The second is scalability. So Bitcoin can handle about 7 transactions per second at most, Ethereum 15 at most, and that's not enough if you've got telemetry coming in from millions of devices at many transactions per second.
Right. Yeah.
So it's just not feasible in these proof of work
Yeah,
technologies.
usually they can be pretty slow.
They're very slow.
Like December last year for Ethereum, I was trying to make some transaction, and at that point, CryptoKitty was really popular.
Yeah.
My transaction actually got stuck for like a half day or something.
No, it's just unacceptable. I mean, if you're trying to buy a cup of coffee and you got to wait half a day for the transaction to clear,
Yeah, that makes sense.
it doesn't make sense. The important problem, though, is security.
Right.
And these other technologies, including EOS and IOTA and Stellar and all the other altcoins that are doing it, at best have just modest security.
Okay.
And I'll tell you what that means. So the fundamental measure of security in all of these blockchains is something called Byzantine fault tolerance. So it's sort of a funny idea. It's a cool idea, actually. So it comes from computer science and from game
Yeah,
theory.
maybe explain to people what BFT is.
Yes, I am. Yeah. So right. So it comes from computer science and game theory. And the original problem is this: suppose that you've got Constantinople, and you've got generals, Byzantine generals from the Byzantine Empire that are surrounding Constantinople.
Yeah.
Maybe you've got 10 of them. So some of these generals have taken a bribe and are not going to fight, and some of them are honest and they're going to fight when they're ordered to. Some fraction are honest. Let's say that 60% happen to be honest generals. If you can still succeed in taking Constantinople in the siege with only 60% of your generals, then we say we are 40% Byzantine fault tolerant. So that means we can tolerate having as many as 40% of our generals being dishonest and still succeed in the mission.
Right.
So the question is, how much dishonesty can a system withstand before it doesn't work anymore.
And in the case of Bitcoin and Ethereum, it's sort of like 50%?
So
Because 51% of hashing power can cause like a lot of trouble.
So that's the claim,
Yeah.
right? So the claim is that it's 50% Byzantine fault tolerant. That's an overestimate for quite a few reasons.
Mhm.
Okay, so if you limit the type of attacks and you make certain kinds of assumptions on networks,
Okay.
it may be 50%. But
Right.
if you don't, so an example would be this. The easy way to see that it's not is almost all of the hashing power lives in mining pools.
Yeah, well, pretty much all of them.
Yes, right. So 3 mining pools, 3 collectives of
They already control more than half.
they have. So really, there may be, I don't know, 10,000 nodes in Bitcoin,
Yeah.
but there are 3 companies that have more than 51%. So
Right.
even if you had 10,000 nodes, three agents can
Right.
take over Bitcoin. So I would say that's 3 out of 10,000. So that's 0.03%
Yeah.
Byzantine fault tolerant.
Okay.
So that's just one. There are many other
Right.
problems as well. So
Okay.
it's not nearly as secure as people say.
So how does Geek come in, like solve a bunch of problems, this scaling problem, the slowness, and the security?
So we see the security problem as the most important.
Okay.
And that's because, cryptocurrencies are nice, they're interesting, and they have value.
Yeah.
Several billions of dollars are on various blockchains, and that's important. But what people want to do is they want to put your insurance contracts, they want to put your legal documents, they want to put your retirement accounts, they want to put the New York Stock Exchange, your medical records, all of these things which either have high value in monetary terms or actually high value in data terms.
Yeah.
And these are very important things that are at the heart of any economy and any society. So if 3 agents can destroy that infrastructure,
Yeah,
that's just not a foundation you want to build on. It's just
no.
not acceptable. We think the security is the most important issue. And how do we solve it? We do the following. So all of the other approaches to consensus protocols, they're called, or to validation of blockchains, have one feature in common, and that is that they are node-centric. So the nodes are the computers that are run by people that take transactions, requests, and follow the rules of the protocol and say this is a valid transaction and this is a valid block and we're going to write the block connected to the chain. So they're the ones that are the accountants, the ones that keep track of everything and say yes, this is true. Okay, so that's true for proof of work, proof of stake, what's something that's called directed acyclic graphs. All the solutions that are available center on the nodes.
Yeah.
Now that's problematic because the nodes are the ones that could potentially take transactions and write them incorrectly. They could actually write your tokens into their accounts. They're the ones that write the books.
Yeah.
So it's like putting the fox in charge of the hen house.
But in those cases, other nodes can like reject the block, the invalid block.
They can.
So that chain may not necessarily grow or.
It may not, but it may also, it may. So the problem is that the game theory behind incentivizing nodes not to accept false blocks is weak at best and really actually some incentives to go ahead and tolerate these kinds of things in various contexts.
Okay.
At any rate, it's node-centric, and even if you want to believe all of the security promises, at best, 50% of the nodes could steal everything, and everybody agrees to this.
Yeah.
That's bad enough. You can create those nodes for about $3.5 billion in the case of Bitcoin. If I can steal the entire New York Stock Exchange for $3.5 billion, I'm going to do it. So it's not enough.
Right.
But it's easier than that. But even if you believe it, it's still not that hard. Okay. So the nodes are the ones that choose. In our case, though, we reverse this. We have a protocol called proof of honesty. And the way the proof of honesty works is that the users, the ones that actually have tokens on the chain, the ones that don't want their tokens stolen, have the ability to run what's called a user client, which is just a piece of software that's an interface that lets you do transactions. And in our case, what this user client does is it runs the protocols as a background process. So you as a user set up your client, it's running, it's looking out at the blockchain that you want to write transactions to, it's seeing that all the signatures are correct, that the Merkle proof is correct, that the Bloom filter is fine, all the protocols are being followed. And it's doing this as a low-level background process. It's not using up a lot of computational power.
Okay.
And it's adjustable, you know.
So it's basically doing verification that can be done very quickly.
It's like like due diligence. It's doing a continuous due diligence.
Okay.
And if if I'm going to give you 1/10 of a cent to use your phone, you probably don't care. So you either turn it off or you don't even have it at a very low level.
Yeah.
But if you're going to give me 10,000 tokens to buy my car, I'm going to do some due diligence on that chain. I'm going to say, okay, yeah, that chain is honest. Go ahead, I'll take your coins. So users can dynamically decide exactly how much they wish to do. So now users have an ability to determine if the nodes are behaving honestly. So some nodes may, some nodes may not. Let's imagine that some nodes are writing false transactions and stealing tokens. Users can choose, in our case, the case of Geeqchain, to write only to the honest chain. They can identify the honest nodes and only transact with the honest nodes. The dishonest nodes can write all kinds of transactions, stealing coins from people and failing to follow protocols, but ultimately it's a fiction. You know, it doesn't matter. We can prove that it's wrong, and we know that it's wrong. And if you try to give me tokens that are written on a chain, which I know is provably incorrect and is false, then I know that those tokens, if I receive them from you, are likely to be stolen from me later. So there's no reason I would ever accept tokens on a chain that is being falsely written in which tokens are being stolen. So users will systematically choose to write to honest chains. What does this mean? So here's the magic. The magic is that if I have a single honest node, then there's an honest chain being written. Every user can discover and prove that that node is honest. And so all I need is one honest node for the protocols to continue and the chain to be honest. Tokens can't be stolen on that honest chain. They're stolen on these fictitious chains, the chains that nobody believes, and those chains are orphaned. As an example, I could just say I own your car. But that's a fiction. You know, there's nothing to back that up, and if the law and other people don't believe it, it's just a fiction, doesn't make any difference. So we always write to the honest chain, the other chains are orphaned. The incentive that gives the potentially dishonest chains is that, well, why would we ever bother to be dishonest? Because the tokens that we write become a fiction and can't be transacted with anybody. So they're useless. They're just entries in a ledger. So I may as well, the only thing to do is be honest, because that's how I get rewards for writing honest transactions. Being dishonest is just throwing everything away. I don't get anything out of it.
How do you recognize the honest chain?
So basically his question is, say I'm a new user to the space, and then in front of me is a fork, one fork and the other fork. How do I tell which is honest or which is not honest?
You push the button on your user client and say, is this honest or is this dishonest? We don't ask users to do anything but run the client.
So this verification is sort of done on the client software?
Automatically, and the only thing the user might want to do is change the level of paranoia. You know, do it intensively, look back 50 blocks, look back all the way to the beginning, look at the Genesis block, or look at recent transactions and make sure everything's going, you know, so. But no, user doesn't have to know anything except check. It's correct because my client says it's correct.
Cool. So this Geeqchain, where do you see it in the future? Like, what's the end game for Geeqchain? What's the application for it?
Well, so we view it as a chain which solves the security issue. We get actually that in itself, I should say, that gives you 99% Byzantine fault tolerant in the following sense, that it doesn't matter how many liars there are. If there's a single honest man, it's enough. So we could have the entire hashing power of the NCSA, of China, of North Korea, of Russia, attacking the chain and writing falseness. If I'm there as an honest person writing honest chains, the votes of the liars don't make any difference. So it doesn't matter how much hashing power is behind the attack. If there's a single honest agent, it's enough. So that's a very strong security guarantee. We just need one.
I'm just curious. So this is claiming almost like a 99% Byzantine fault tolerance.
Yep.
Is there a paper written for this?
Yes.
And is it peer reviewed?
Well, there's a white paper that's written
Okay.
for it. So this paper, it's actually funny.
Okay.
It's not peer reviewed. So
Okay.
if you look at you can find the work I've written. I have a WordPress page actually.
Okay.
So if you look at jpconley.com,
Okay.
it will take you to a WordPress page that has all of my research and all the stuff like that. So I have a lot of, 60, something like that, peer-reviewed papers.
Okay.
I don't know where I'd submit this paper because actually it's not a very complicated piece of game theory.
Yeah.
So if I submitted it, they'd say, oh yeah. So it's funny, economists only like things that are complicated, but this happens to
Okay.
be simple.
Interesting. So, okay, let's go back to the question. So where do you see this Geeqchain to be applied? Where's the application of it? Where do you see it being used?
Well, so we see it as being a challenger, we think a killer of Ethereum and IOTA and so forth. These solutions are not solutions. They don't do what we'd like them to do.
Right.
And they don't provide the security guarantee, they cost too much, and they're just, blockchain is an incredibly interesting idea, and it can do a certain class of things in a revolutionary way to allow decentralized, trustless interactions, to have distributed business processes be able to be contained in some kind of data system like a blockchain instead of a closed database that people have to get permission to access.
Can you maybe just give us some example of like actual real use cases that potentially blockchain can be applied?
Sure.
Yeah.
So the easy ones are this.
Yeah.
So here's my favorite use case actually. So because I'm at Vanderbilt. So Vanderbilt and most universities and many corporations have internal payment networks.
Okay.
So the way that works is that the students have a student ID, and they use it to have a student account. They can buy books and food and pizzas and various things the university sets up with merchants that are local. So it's all internal because the money is first paid to Vanderbilt, and then Vanderbilt lets students spend it over the semester using their ID card.
Yeah.
Okay.
Okay, so it's just a payment. So it's like PayPal, except it's internal to Vanderbilt or Harvard or whatever. Now, the providers that offer this service charge about 6% on transactions. Now, that's mysterious. Why would you pay 6% on that transactions? It's mysterious. But the only things I can come up with are it's Vanderbilt doesn't have the expertise, and neither do other universities, and Oracle sucks. It's just too hard to implement for a university to implement it on. It should just be on the internal database. I don't know why it's not, but it must be too complicated to do it, too hard to do it. There's another reason actually. If you're transacting tokenized dollar bills, there is some what do we call know your customer and any money laundering things you've got to set right. And so universities may be a little bit concerned about doing that. All right, so it's a massive market, and every university has one of these. So what do? This is a trivial application of this. Our system lets you. So I should say, part of the architecture is we have what are called federated instances of the chain. So part of what lets us scale is that we can spin up brand new editions of the blockchain. And these blockchains can share transaction flow within a single kind of application, or you can create federated instances that don't communicate with one another. So maybe Harvard's internal payments network doesn't communicate with Vanderbilt's internal payment network, but there are 6 different chains that are validating all the Vanderbilt transactions because the load is so high.
And this is something that Geeqchain can potentially be
so
used.
this is part of the fundamental architecture.
Okay.
Right, so this is built in.
So it's not only a chain, but also there's some kind of federated things going on there.
Well, it's all Geeqchain. Okay. So the way that you get it federated is that if you want an application, Geek Corp issues you a Genesis block.
Okay.
And then on that Genesis block, you can build your application. So one of our ambitions is to have a better system than ERC-20.
Okay.
So ERC-20 is the smart contract that all of the Ethereum businesses are built on. So you can build these applications on Geeqchain easier for reasons, like probably not enough time to go into.
Okay.
Cool. But back to Vanderbilt, part of what we can do in this structure is we can issue native tokens. We can issue Vandybucks.
Okay.
So the Vandybucks are tokenized student dollars, and the students can have accounts just like they have.
And they will be able to transfer those tokens around within the network.
Within the network,
really
right.
minimal pay and really fast.
Really minimal payment.
Okay.
And what makes this particular application, sort of attractive is that actually, because it's internal, all of the students and all of the merchants are KYC'd and AMLs.
Right.
We know
Yeah.
them, right? We couldn't do this for the general public because
Yeah.
tokenizing dollars is illegal because you might be a criminal,
Yeah.
right? But all the students have been vetted, so we can actually do these internal payment networks. So now think of it. You've written this for Vanderbilt, but the application for UC Berkeley is identical.
Mhm.
It's just rebranded, right? It's the same application.
Mm-hmm.
So you can generate this application and then have it deployed 3,000 times or 10,000 times.
Mhm.
And you don't have to worry about the load because these chains don't interfere with each other. They don't squeeze out one another's transactions. It's inexpensive and it's high security. So that's one of hundreds of potential applications.
So in the end, where do you see this blockchain space going in general? Do you think it's going away because it's a bubble, or?
No, I think a lot of the platforms are going away.
Right.
And I think an even larger share of the businesses being written on ERC-20 are going away.
Mm-hmm.
Most of those businesses are not businesses, they're just not well thought out.
Yeah, I actually agree.
It's just a scam, right?
Or I actually talked to some projects in Ethereum during the Icon. I asked them like, how do you guys sustain yourself? Basically, you can't just keep selling your token for so long. You
No.
can only do that for so long, and they didn't have an answer, right?
No, so there certainly are scams out there, but I think a lot of people are sincere and they want to do the right thing, and they even have maybe sometimes a social vision,
Yeah.
but they don't have a technological vision, and they certainly don't have a business model.
Right. Yeah.
And in many cases, sometimes they don't need a blockchain for what they're going to do. We've
Right.
got it done on a database.
Yeah.
And even they do need a blockchain, they often don't need a token on that blockchain.
Mhm.
The token exists only to fund the system.
Yeah.
So tokens are useful, but they're only useful for very specific things.
Yeah.
So yeah, I think that most of the ERC-20 businesses will disappear just because they're not well thought out. It's like the internet bubble of.
So what about the rest of the blockchain projects? The ones other that's going away, or like where do you see those platforms going potentially?
So I think Bitcoin has some legs. So you should never trust an economist who's about to make a prediction, because we're no better than anybody else. We can make guesses, but I can do analysis. You give me
Yeah.
inputs, I can give you outputs.
Mhm.
My guesses are just guesses, right?
Okay.
So my guess though is that so Bitcoin is an awesome piece of computer science.
Mhm.
It's just absolutely beautiful mathematically.
Great.
This idea of creating the Merkle tree and the immutability is just a piece of genius.
Yeah.
It's
Mhm.
elegant, beautiful, wonderful.
Mhm.
But it can't handle the load that it's supposed to handle. It's just not, it cannot scale.
Yeah, I agree. So basically what I think is that currently the scaling issue is facing pretty much all the blockchain projects out there.
Certainly proof
yeah.
of work projects, yes.
Right, if they don't solve that problem, then
Right.
it's not, they aren't going anywhere.
No, that's right. They can't go anywhere. But still, the thing about Bitcoin is it does provide this sort of built-in anonymity.
Mm.
And that's attractive for a lot of people. So I think Bitcoin will have legs. It will probably last, I don't know. But it may go up, may go down. But I don't see Bitcoin dying immediately.
Okay. So you said that Bitcoin has some legs. What about Ethereum, the second largest?
So Ethereum has a problem that's coming at it like a freight train,
Mm-hmm.
and that's that it's trying to support it's an infrastructure which is too narrow to support what's being built on top of it.
Yeah.
It's
Yeah.
like trying to build an upside down pyramid. It just is not able to support this. So what's going to happen? We have a lot of disappointed people. We have transactions costs going higher and higher as demand increases. So now what? Does that just drive it up because now there's huge demand for this very limited transaction space, or do people just abandon the platform completely and go somewhere else? It's going to be difficult and unpleasant.
Right.
What that will do for the value is harder to guess. Now, of course, you're going to Lightning networks and other things. These are problematic because they don't provide anywhere near the security guarantee that the proof of work does.
Right.
So if you're willing to accept a lesser security guarantee for rapid transactions, well, okay. I mean, it's a trade-off that one might make, and maybe that will have, again, the effect on Ethereum value I couldn't even begin to guess.
Okay.
Yeah, there's so many competitors for Ethereum right now, right?
Well, so the competitors are all really coming in two forms. They're coming in as some kind of, well, either it's Fabric, which is, you know, a permissioned blockchain, which is what the enterprises are using, which is not a blockchain. It's very mysterious what they want to do.
I never really understood what's the purpose of a private blockchain. It's no better than the database.
It's actually worse.
They can't solve the speed. They must be very slow if you were put everything.
So you can only that's right. Yeah. So actually it should really, an important thing to understand is that blockchain is like a lobotomized database. It's incredibly dumb.
Yeah.
All it is a ledger. Literally it is, here's an account, George. George has 12. That's all the data it has. Sometimes they have some other data objects, but it's that simple. A spreadsheet at least says, George has 12, he bought it on May 14th, other columns that is more elaborate. And of course, a relational database has complicated tables that's even more useful. Ledgers are the dumbest kind of data object you can possibly have. Right. So you're throwing away all kinds of utility when you go to a blockchain. What do you get for it? You get immutability, you get provability, you get decentralization, anonymity, many things you get for it, but you lose a lot in the data sector. But if you have a private blockchain, you're giving up all of that stuff because you've got a limited number of agents who are doing something to a Merkle tree, verifying it in some fashion, but it doesn't mean anything because it's all the people you trust anyway. So, you can mutate it, they can mutate it, you can agree. You can't verify it because typically these entries are private. They're encrypted for particular agents that are involved in the transaction. So you might have a transaction, you to him. We can record it on the blockchain, but as an encrypted object. So I can't see that you've actually not exceeded your account or that you've not double spent. I can only see encrypted objects. So there's no verifiability, there's not really immutability, and there's not enough of a distribution of nodes for it to be trustless. So it's trusted, it's mutable, and it's not verifiable, and it's stupid. So why? I just don't understand why you want to go that direction.
Lots of people try to use the smart contract as the backend. Because they thought, oh, you are the smart contract, you can write some piece of code. That's just you don't have to have a real backend for the application.
Yeah. So smart contracts they're not magic. I mean,
it's very limited.
It's limited, and they can do certain things. They can do, if it's Turing complete, they can do in principle anything that you can write in a logical sentence. But smart contracts have a number of flaws, and one of them is that they can only interact with the real world outside of the blockchain. So, you claim that you've delivered a load of bananas and that the boxes were full. And then, the smart contract says pay you. But how do we know the boxes were full? It was a guy that said, oh, these boxes are full, but that guy could be lying. That guy, So the smart contract's only as good as the data that goes into the execution. So it doesn't solve that interface with the real world.
That's
so true. It kind of makes it magical, and it does some things, but it doesn't really solve the problem fundamentally. It doesn't generate trustlessness in the way that you'd want it to.
The other day I just talked to a guy. He's one of he works for Total Network.
I know it.
Yeah, they also try to solve the scalability of the Ethereum, something like that.
Yep.
So basically, he told me the blockchain is not used for all the cases. It just try to solve the trust. If your system application have the trust issues, that's the best case for blockchain, not for everything.
No, that's right. if you can trust people, there are many easier ways to solve everything. The point is that you can't trust people. I mean, I don't trust Google. I don't trust the government. I trust you. You'll trust me. But no, I mean, if you're dealing with people that are at a distance you've never met, or machines that could be doing anything at all, you need to have some kind of trustless way to interact, or else you'll choose not to.
So, as an economy professor, can you talk a little bit about the money aspect of Bitcoin?
Sure.
Like, what do you see it? Do you see it as money? Do you see it as a commodity? Do you see it as like rare metal?
No. Okay.
Well,
So
how do you see it?
So.
What kind of thing is it?
So. So the first thing you have to understand is what money is.
Right.
And what economists say is that money is trust.
Okay.
Okay. So the reason we say that is that, you know, if so here I have some money. So here's a piece of money, right? There's another piece of money.
Okay.
This was in Britain. All right. So there are two pieces of money. So these pieces of paper were blessed by treasury wizards.
Right.
You know, they put pictures on them and they wrote amounts on them. There's no intrinsic value in this.
No.
None at all. I mean, why do you accept this from me? Because you believe that he'll accept it from you later. So that's the trust.
Yeah.
You trust that somebody else will take this if you take it from me. If you didn't trust it, you wouldn't take it.
Right, exactly.
If I gave you,
otherwise it's a paper.
right, if I gave you
Right.
beans or I gave you coffee, then that might be something you take without the trust.
Right.
But these are just things we take because other people are going to take them. Bitcoin is the same way. The only reason to take it is because we believe other people will take it.
Oh, okay.
So money. So in that sense, it's just like money. It's
Okay.
no worse.
Right.
Money is nothing. Money is just an illusion. It's based on trust.
Interesting.
Now, what is the value of money? So it's very useful because it helps us solve what's called the mutual coincidence of wants problem. So you want to buy a cup of coffee. You know, for me, I would die without it, right? If I want to get a beer, I could go say, well, can I give you 6 minutes of economics lectures? I'd never get a beer, right? So I couldn't get the things I wanted. I had to trade the things that I own. So instead, I give lectures, and somebody gives me dollars, and I take the dollars and I buy beer, and that makes money incredibly useful, right? So it solves that issue. So what is the value of these pieces of paper? It depends upon a couple of things. It depends upon how many of them exist. The more that exist, the less valuable they are.
Right.
It depends upon, and this is very important, how quickly they transact. So that's called velocity.
Okay.
So velocity means that, suppose that we had an economy and and we traded, I don't know, pigs. So we had 200 pigs that were traded every day, and we had some pig dollars that we were using to buy these pigs. If you had 200 pig dollars that were buying 200 pigs a day, and the dollars only circulated once a day, then we'd have an equilibrium where each pig dollar was worth one pig.
Okay.
But let's suppose that they circulate more quickly. They go to the person that sells the pig, and he puts it back in the hands of the person that wants to buy a pig through some other mechanism. So suppose they go back and forth 100 times a day. Then we could have only 2 pig dollars, and they would be able to buy 200 pigs, right? They just circulate 100 times per day.
Yeah.
So that means still, if we had 2 pig dollars, they'd be worth 1 pig each. But if we had 100, they'd be worth 1/50th of a pig.
Interesting.
So how quickly the money moves, it affects how much it's valued.
Is this something being taught in university?
Sure.
I vaguely remember a formula.
You remember macroeconomics, right?
Something around MV equal to PT.
That's exactly it, right? So that's called the quantity theory of money.
Okay.
And all money is subject to it, including crypto tokens.
So, in some sense, you think, well, in some sense, we can sort of almost come up with a model for Bitcoin price, in a sense, such that if we know the Bitcoin velocity, and then we know like how much things are actually being purchased around, like the economy of Bitcoin.
So
then we can roughly tell like the value of it.
So the answer is yes and no.
Okay.
So yes, that's true, because this quantity theory of money is an accounting identity. It's not a theory. It's just a fact. Has to be true.
Okay.
This works out with the accounting, right?
Okay.
But what's uncertain is, number one, how quickly the velocity is endogenous. It's a choice.
Right.
Do you hold your dollars or do you get rid of your dollars?
Mm.
In a country with hyperinflation, you want to get rid of your dollars as quickly as you can for whatever it is you can buy. So dollars move extremely quickly, which contributes to the hyperinflation, right? So that's not a fixed thing and nothing you can estimate. It can vary according to people's choices.
Okay.
And then secondly, how much value is there in the economy? Well, if people stopped deciding that Bitcoin was useful for transactions, we would only want to transact $1 million a day in Bitcoin, and then the value would be very small.
Right.
But what causes that? Again, choices. People's choices for whatever reasons that are outside of my ability to predict.
So it's a highly theoretical formula that doesn't necessarily have practical coefficients that can be plugged in.
Well, I'd say it differently. I would say that it's a factual thing. It's an accounting thing. It's not really a theory.
Okay.
But it's in the real world we can estimate these things. We can see the real stuff being produced.
Right.
We know what's going to be bought and sold with dollars.
Right.
We have some historical reasons to believe something about the velocity.
Okay.
And there are things in the economy that slows the velocity fundamentally.
Mm.
The Bitcoin. So here's I did some math.
Yeah.
So this is only approximate because the values have changed.
Yeah.
But the quantity theory of money, if you assume that the amount of value transacted on Bitcoin per day, which is on the scale of $5 billion or something like that, if you assume that's fixed, and Bitcoin velocity is on the order of 2 to 5% per day, empirically, then the value currently of $7,000 is the correct value according to that equation.
Right.
But
Okay.
it's theoretically possible because Bitcoin blocks are written every 10 minutes.
Okay.
There's 144 times a block is written per day. A coin could transact every single time a block is written.
Okay.
And so you can calculate something like 2 billion times, given the number of 2 billion Bitcoins could move in a day, right?
That's a lot.
Right, so that means that if you have $5 billion worth of value transferred, you could support that with a Bitcoin value of $2, $2.50.
Well,
It could be, but that would require that everybody moves Bitcoins incredibly quickly.
Yeah.
But right now they're moved pretty slowly.
Yeah. I think I read a report somewhere that says roughly 5 million or 3.6 million of Bitcoin were pretty much lost because once they were generated, they never moved around.
Right, so something like 25% of Bitcoin hasn't moved in 5 years, and about 40%, 45% hasn't moved in 2 years.
Do you see Bitcoin ever replacing, say, a country's currency or?
No. Well, not Bitcoin. Bitcoin it doesn't have enough transactions volume to make that possible.
Right.
Could a cryptocurrency replace it? Sure.
Okay.
Yeah, but not Bitcoin.
Okay. So where would the potential cryptocurrency be? Would it be issued by some country, or do you think it's going to be a community thing where they just sort of came up with?
Anything could be true. No, the thing about cryptocurrencies is let's just imagine that Geeqchain can do all the things.
Right.
Geeqchain could be this. It is technologically possible for it to be the currency.
Yeah.
And the structure of Geeqchain is that once these tokens are issued, and once the genesis blocks are created, we can't shut them down. We, as a company, can't, and governments can't. It's like Bitcoin in the sense that once it's in the wild, it's distributed. There's nothing we can do about it.
Yeah.
And if people decided they wanted to use it as a currency, we could neither say yes nor no. It would just be whatever people choose to do. And somebody else could have another cryptocurrency that's better for whatever reason, and maybe they could compete, or maybe they would use it instead. So it's possible, but there's no good reason to predict one way or the other.
Oh, okay. Interesting. And then do you have any more questions?
What's the status of the Geeqchain?
So the white paper is written at the first of the year. The yellow paper is written. Yellow paper is all the technical specifications and details and so on. We have the core team established. We've got advisors. One's at Microsoft, one's at GM, one's at VC. There's lots of. One was a friend of mine from high school, if you can believe it, who was I think he was a 12th employee at Intuit.
Oh, really?
And he's been in 8 startups, I think he says, which 2 have been successful. And so he's deeply embedded in the valley there. And so we've got some very good advisors and a very good team. We've gotten, it looks like we're now gotten a pretty large amount of funding.
Okay.
We're probably, so we don't know, we haven't added up the numbers yet, but my guess is that we're above $10 million, maybe substantially so. And so literally, we just got back from Gibraltar, and so the CEO, Rick Aselstein, and myself, and we're now in the process of hiring coders, and we've got a CTO who's sort of written sort of an experimental piece that sort of begins to prove what it can do. But we're hiring coders, and we'll be writing this thing in earnest within a month, I would say.
Oh, interesting.
Yeah.
Cool. Sounds good. Yeah, we hope.
We hope you guys are successful.
We do too.
Yeah.
We're very optimistic. It's a very interesting technology, and
Cool.
we've got some good reactions from it.
Cool. Yeah. 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 Thanks again to join our show.
Oh, it's a pleasure to
Yeah.
be here. Thanks so much.
I think that.
Thanks for sharing the knowledge
Yeah.
of your
My pleasure.
Yeah,
professionals.
yeah, you are the first professor we are. Just remind me the time when I was in school. Yeah.
Well,
Yeah,
When the
right.
professor talks, we don't understand anything.
Yeah.
well, I hope it's different.
All right. Thanks for watching. See you next time.
Okay, thanks so much.
Yeah. Thank you.
Take care, guys.
Yeah. Yeah. Bye bye.